Yeah, so welcome to the Autoware COE members meeting. And so today we'll go through the list and we'll go through member updates. And let's see, we'll just hear from you what activities you're focused on as part of your Autoware projects and how we can help you also. Yeah, so maybe we can start with Chinmay Tanmay from Clemson, as that's on the top of the list here, and I'll share the list also in the chat.
Hello everyone. So the project that we are working on at like our group is working on is pertaining to AutoDrive and AutoWare integration, where AutoDrive is something that we have created and we want it to be integrated with AutoWare stack so that deployments and scaling of these deployments becomes more integrated and convenient in general. So this is a high level presentation. We'll just skim through it. Dr. Mangaram, can we just get an idea of how much time we have to talk?
About 5 minutes, 5 minutes.
Okay. So we'll make it quick. Uh, so this is a presentation. A good thing about this is that this has been accepted at IEEE ASME AIM conference and published. Uh, so just quickly going through this, the main idea was to you know address the challenges with autonomy validation, and here we are talking about vehicles across different scales and operational design domains. There are a variety of software stacks and APIs out there, and we can have an option of testing purely virtually, purely physically, or in a hybrid setting. So these kinds of challenges were the main address point of the paper. And how can we push the boundaries to now uh, use AutoDrive with AutoWare stack was the main focus. So for those who might not be aware about AutoDrive, it is an ecosystem that we are developing, wherein we have three distinct components. First is the dev kit, which has a flexible set of APIs and tools for developing autonomous driving algorithms. And this is where we are now interfacing it with the Autoware stack. Next is simulator, wherein we can do virtual prototyping and verification across parameter sweeps and potentially even in the cloud, as we'll see. And finally, the test bed where we can do the physical deployments. Now, these are all examples with a single vehicle to show the examples, but as we will see, we were successful in deploying this across different scales and ODDs. So these are some of the vehicles that we have. The rows indicate different scales, and in terms of the columns, the first and the third column are the real or the physical twins, and the second and the fourth column represent the digital twins of the same vehicle. And these are the four vehicles that we will be particularly considering or discussing in the further slides. So uh, this is one of the vehicles called Nigel, which we started off the AutoDrive ecosystem with. And then we were able to successfully expand it to other vehicles like the F110, as most of you would be familiar with. Then in the mid scale, we have the Hunter SE, which is an Ackerman steered platform by AgileX. And finally, in the full scale, we tested and deployed things with the OpenCAV, which is an aftermarket integrated vehicle, autonomous vehicle that we have at our facility. So all across all of these vehicles, the common deployment was using AutoDrive simulator or the testbed or whatever component of that, and the AutoWare stack. So we tested across different environments. I will not belabor the discussion here, but each of these environment targeted either a distinct ODD or different features in terms of the environment representation. And as we will see in the deployments phase, we were able to even control the environment variability. And this could be in terms of the times of the day or the weather uh, conditions that we are working with. And while we, as you can see, have a whole host of APIs and HMIs that we can work with, the primary target for this work was Autoware. And in one of the future slides, we will also see the different HMIs potentially in action. So this is the deployment with Nigel, where the core focus was to uh, demonstrate autonomous parking application with sim-to-real transfer. And in terms of the sim-to-real transfer, it's worth mentioning that we did not change any perception parameters or controller gains, and we were able to do a zero-shot transfer from simulation to reality using this framework. The same applies to F110. The only difference here is the operational design domain, wherein we are now targeting a little bit more towards the racing application instead of just parking. And again, we were able to do sim to real transfer without changing any perception parameters or the controller gains in this case as well. Coming to the mid scale, here we experimented with on-road as well as off-road navigation. So the top row indicates, again, a similar parking application wherein we have a simplistic environment representation. And then in the bottom, we can see a deployment in the off-road area wherein we are using a point cloud map now for localization and point-to-point navigation from like a designated source location to the designated destination. And finally, we also did a similar case study with the full-scale vehicles. Uh, this was targeted towards on-road domain. Again, the application remains autonomous parking, but here we experimented with 2D and 3D representations to see how it affects the environment representation. So in the first row, you can see a simplistic environment representation wherein 2D maps or surrogate maps could be sufficient for navigation. But in case of higher fidelity environment representations, which is what we would most likely encounter in the real world scenarios, 3D point cloud becomes a necessity or a benefit. So these were some of the highlights
So
from
in
the
this
AIM present.
case, Tanmay, on the right hand side, you're showing the real, or it's still in simulation, the point cloud.
Could you repeat that? You mean
Like at
the
the right bottom, you're showing
right?
the map, right? And
Yes.
that's just in sim, no. Or do
Yeah.
you
So
have
it's
like
the
a sim
exact.
and a real?
So it's the map of the scene that you see on the left in the simulation.
Oh, in the simulation, okay.
Yeah. And then apart from this, I'll probably if we have a couple of minutes, I'll just ask Tanmay to give a glimpse of the sim racing league that we were able to deploy at IROS and CDC uh, in the past few months.
忘了要旁听一个
We can't hear you.
Chinmay, Tanmay, are you all speaking? Because we cannot hear you all.
Yes, Dr. Mangaram, we were speaking. I think Tanmay's mic might not be working. I can just ask him to use this.
Okay.
Let me just back up a few slides. Sorry about that. So yeah, the idea was to use the F110 digital twin that you saw in earlier slides to have a simulation-based competition for the F110, where teams from all across the globe could now have the F110 competition accessible. And more importantly, this could be a good way of tying in reproducibility and benchmarking within the uh, competition setting. And then, of course, these can also be expanded further for full scale or off-road applications. And we also have plans to now put this in the cloud, hopefully for the ICRA competition this year itself. But if not, at least by the end of this year, we definitely wish to have a cloud setting where instead of not, having just local resources, we can also have a common cloud platform, and the AWS credits can hopefully go there and put to some good use there. So that's definitely in the plans. And then, of course, the idea is always to be able to transfer this policies trained in simulation to in reality. We had a team at IROS where they could successfully do this, and they participated both in the sim racing league as well as in the physical racing league, and had a zero shot sim to real transfer. So here is just a quick overview of the competition. I won't go into the details, and the video that you see here also talks a little bit about the competition summary. And I think Chinmay has just posted a link to that in the chat, so I won't belabor that. The competition looks something like this, where we basically had containerized deployment, and there were a few options that the users could choose from in terms of distributed computing or headless computing, just to reduce the computational overhead across different teams. And this now enables reproducibility and benchmarking, as I said, bringing Autodrive and F1 together to now unlock the full potential of autonomy in terms of both physical and simulation-based competitions and research. And then these were some of the metrics that we used to mark or benchmark the performance of different teams and have a detailed analysis of the and impose race standards across different teams that we have. And the idea was to now also expand this, and we also have a few, especially when I talk about CDC, we also had a few teams that are now requesting or already are on their way to deploy things with Autoware. So again, with CDC, most of the stuff shown initially is the same. The only difference here is that we had a controls community now come in the first time. Of course, there was a physical race as well. Uh, but this is where we actually saw more learning-based algorithms than IROS. IROS, I think we had a few teams, but here there were more learning-based algorithms. And like people were really picking things up. And this is where we actually had a few teams ask us whether Autoware would be a good stack to now have their autonomy algorithms, and more importantly for the F1 racing. And this is where we first had a few teams submit things with Autoware, and hopefully we will have more and more teams now engage with Autoware. But another thing that's important here is now we have ported the framework to support ROS to Humble, and that's where we are now also hoping to shift the entire framework of Autoware Autodrive integration towards Humble and the latest release of Autoware, so that users can now leverage the latest and greatest features of Autoware with Autodrive. So I think we went a little bit over time. I'm sorry about that. But yeah, if there are any questions, we can hope to answer them. Or if not, if there is no time, then we can move on to the next presenters.
Yeah, thank you so much, Chinmay. Tanmay. This was a very good update, and I think our follow-on is with Pooja and and Mike is to figure out now how to integrate this within the Autoware universe and make it like one of the publicly available digital twin sim to real environments that folks can use. I think hosting it on AWS is definitely the right direction for the next competitions. Yeah, thank you. And any
Raul,
other questions folks have?
yeah, hey Raul, just a quick question. Great work, guys, really nice. So in terms of using it from an Autoware perspective, and I know you guys also have a Pix kit, but I'd be interested, and Alex is on the call too for Carballo, who also has a Pix kit, some physical hardware. Do you have any thoughts on? I mean, I'm interested in exploring the validation, verification, putting it on an actual vehicle here. that we have available, and I know you guys have one too. Are there any thoughts on that? Like, what would it take to do something like this on the Pix kit, as an example?
Yes, so in the presentation, you might have seen our deployments currently at the small scale, including Nigel as well as the F110 vehicles that we have. But we are currently working with the Pixkit. We are also in the process of parameter like system identification and bringing the Pixkit into Autodrive Simulator so that we can work with its digital twin and then do zero-shot transfer, hopefully, even at that scale. And as further scaling, we are also currently working with the OpenCAV to do the same. So I hope I
Additional questions, but I'd certainly like to, once it's
absolutely,
settled,
yeah,
duplicate it here in Detroit and demonstrate what you've done and all that sort of stuff. So again, awesome work. Thank you.
thanks.
Great. So we can move to the next. So I think there's Anveshan and then Josh.
Yes, so yours, or should I just give an update? Sorry, I don't have a presentation ready, but I
That's
can
okay.
give
That's
some.
okay. You don't need a presentation, but you can just describe your project and
Yeah,
what the current
maybe I
status.
will share my screen. I just wanted to. So just to give you a reference, can you see my screen?
Yes, yes.
Yeah. So this is a platform, a research platform that we have at TUE. So it's a Toyota Prius 2017, and which is capable of driving autonomously. But it really works on a really old version of Autoware that we again migrated to ROS2. But right now we are actually porting everything to Autoware Universe. But the main thing that we're working right now is this setup. That's we are working on surround radar, not perception, but localization. So we have 4, not imaging, but HD radars, so Continental 5th generation. And we have a LiDAR, and we have one stereo camera at the front. And we are, with this setup, we want to facilitate, let's say, a benchmarking data set, and that we want to publish in IROS this year. And what we will provide is that we have all of them synchronized and calibrated. And we also will publish our own radar SAM pipeline called RioSAM, which is an extended version of LeoSAM, which is working on radars. And yeah, that's the main update. And if you want to see some results, let's say the point cloud that we generated from the map that we generated from the only the radars is this.
And what kind of radars are you using?
So these are Continental 5th generation. To be exact, is 548 RDI. So this is a high definition radar. And if you want, it's like it has 12 transmitting antennas and 16 receiving antennas. But these are not the, let's say, the greatest high resolution, let's say high definition radars, which might have, let's say, 48 transmitters and 48 receivers. And let's say for each scan, it can generate up to 800 points, each one of the radars.
And what's the benefit of having a radar-based system versus a LiDAR-based system?
Yeah, so the main advantage is that we want to show that it works in really difficult weather scenarios. Let's say when we have fog or snow, let's say technically this radar signals are immune to those. And we have really seen, let's say when we were also recording data in really foggy areas, foggy scenarios, and since we were only using LiDAR-based or point cloud-based localization system, it really struggles. And then we want to say that this is a much more redundant, can be viewed as a redundant system, which works in, let's say, all kinds of a bit better, let's say, which is adaptable to other weather conditions, adverse weather conditions.
And what kind of localization algorithm are you using?
So for our RioSAM, we use GICP, fast GICP to be exact. But we have also tested this, let's say, combined radar point cloud on a LiDAR-based map, point cloud map, that there we have tested with NDT. And there also it works.
Okay, okay. Very interesting. Yeah, yeah.
Yeah, so we are also really happy to see that it works on, let's say, the maps generated from LiDAR point clouds. And it was also quite exciting for us also. And we also want to show, like, publish those results in IROS. And we
Okay,
thought
so
of having something in this, let's say, IV workshop, but we do not have time to make a, let's say, good paper out of it. So we just are aiming for IROS, and hopefully, yeah, people will like it.
okay, and then you use the LiDAR as a ground truth or a comparison.
No, so for ground truth, we have OXTS post-processed RTK GPS data, and we also do a comparison with LiDAR-based localization. So we
Oh,
have the same thing, yeah, LeoSam running with LiDAR, and we do analysis on the errors, yeah, trajectory errors.
very interesting. Yeah. I mean, it's not that there is still time for the workshop, for the IV workshop, the Autoware workshop, but I think the IV conference deadline is earlier.
I think the workshop deadline is also, I think, next week or something to submit the six-page version of the paper.
Okay, okay. Maybe Alex, you
Yeah.
can give us a brief update on that next. Yeah.
Okay, then I will stop sharing the screen.
And what is so the your like the goal here is to show like to show the validation of
No, the goal is also to share. So we want to share this data set to the
right.
community, and then we have also want to share a benchmarking data set, let's say.
Okay, okay, very cool.
So then with this data set, you can compare LiDAR-based localization, yeah, LiDAR-based localization, and maybe do fusion if you want, and then yeah, we hope to create more data sets in, let's say, different weather conditions also. So we will extend those as time progresses. But initially, we will have, let's say, some data sets inside this Eindhoven city, and then yeah, then we'll grow on top of it.
Cool. Thank you. Thank you. This is very good.
Okay, I'll stop sharing my
Yeah.
screen.
So I guess one question I have is, as you take this forward, right? How is this related to your Autoware COE project? And I mean, so I guess you mentioned you were working on upgrading the Prius
Yes.
to Universe, right?
Yes. For what we wanted to also do is we wanted to extend this Autoware, let's say, and or with the radar-based localization. We want to see that whether it's working or not. And the other thing that we are struggling a bit right now, maybe just to put forward, is that our vehicle control unit for the Toyota 2007 Prius is not that good. Let's say we use comma AI based solution, the two pandas to get access to the canvas. But this is also like quite, the drivers are also not that stable, and it's like really hard to get like good access to all of the signals. And if there is a solution available for this specific car, let's say 2017 Toyota Prius, it will be really helpful. Otherwise, we really need to again spend some time really debugging some of this the CAN IDs and the signals. Let's say it's uh,
Yeah, yeah. That
difficult
I
process.
think it'll be good to have a follow-up discussion with Pooja, and then he can sort of see how we can best help you also, so you don't you save time and energy.
Yep. Yes.
Yeah, cool. Thank you so much.
Thank you.
Yeah, yeah. All right. Maybe next we can go to Josh and Hormoz and then Rahul. Yeah.
Oh, great. So I don't think I'll be showing slides, but I'll show at least one figure that some of you have seen before and is the most relevant to uh, our aims, goals, and proposed contributions for our Autoware COE project, which is we're calling it a cloud-based autonomous driving software testing and debugging infrastructure. So the high-level goal is for as an Autoware COE project is to provide the Autoware COEs with a kind of test harness or based off of something akin to a CI/CD testing infrastructure And so the figure that I'm actually showing you is very related because we also have an NSF Community Research Infrastructure Planning and Prototyping Grant, which a number of you on this call all are aware of for multiple reasons. And I'll expand into that and related activities as well. So at the moment, the goal here is it's definitely going to focus on Autoware, but what we want to be able to do is, some of you are familiar with like the Autoware Evaluator, for instance. We want something like Tier 4's Autoware Evaluator for the COE. We've actually done things already like pull down the test scenarios from the evaluator. We're able to run it locally, and so we want to be able to use um, pre-generated, whether manually or automatically, test suites um, for Autoware, like the Autoware Evaluator, but also based on a bunch of state-of-the-art automated software test generation approaches like the ones shown here, make that available through the cloud. So, for example, through the AWS and the AWS credits that the Autoware COEs are making available as part of the Autoware COE projects. Um, and so we also want to be able to more broadly, and that's in a sense at least one of the wider visions of our NSF planning grant at the moment is to bring in as many simulators like Carla, like AW Sim, or even simulators like the one William on the call is working on, but also incorporate other autonomous driving software. So for example, maybe we would want to test different autonomous driving systems along with Autoware and simulation, whether that's Apollo or AutoDrive, for example. So we've been meeting up with Tanmay Chinmay Venkat to push that forward. Uh, and beyond that, we're also running um, organizing multiple workshops. The one that is coming up soon is our plan for March 26th and 27th, a local UCI workshop related to this infrastructure and the Autoware COE project, where we want to elicit the right requirements and early design to support the Autoware COEs, Autoware community, the software testing community, people in transportation, and security. So one of the big things is we want to help ensure and analyze the security of Autoware, provide even move toward, for example, not just finding the bugs, but automatically debugging and fixing um, any bugs we find. Uh, and I don't know to what extent people on the call are aware of this, but at the very least, the software engineering community has spent a lot of time on automatic program repair. Companies like Meta use it for instance, for um, some of their projects. And so beyond that, uh, another related project is, and worth announcing, some of you are aware of this as well. I've been very fortunate to be awarded the NSF Career Award, which is highly prestigious, very good for the fact that I'm up for tenure, and in no small part due to the support of Autoware, the Autoware COEs. Raul Mangaram actually wrote one of my collaboration letters, and through that, we'll be able to do more physical world testing. We already have a Pix moving chassis. We're in the process of ordering one of the whale dynamic vehicles as well. So through that, and also through collaborations like the one with Clemson, we're hoping to do a wide variety of automated testing and debugging of Autoware, build that test harness for any and all of you to use. And yeah, if anyone wants to know more about the workshop on March 26th or 27th, or the one that we're holding at the top conference in software engineering the International Conference in Software Engineering, ICSE, in Ottawa that is happening on April 29th. Thanks, everyone.
Cool. Thanks a lot, Josh. So many good updates. And once again, congratulations on your career award. I think these
Thanks.
workshops are so relevant. And also, I believe, like, the work that William is doing and Chinmay and Tanmay, we could sort of bring all of that in and maybe, even just um, I don't know if you thought of like, just having also like just an examples of, you know, bug detection and then correction, say within the perception, within control. I mean, we inject those bugs, we know they're known, and almost as an example of like saying, look, here are examples of, how these would affect the behavior of the system or how some are very like kind of gross behavior changes and some are more subtle. And then, we could sort of at least work on a, you know, just a choreographed set of, bugs as illustrations and then, build from there.
Yeah, absolutely. That would be great. We've also been building data sets of confirmed and fixed bugs, fixes, fix patterns. At the #2 conference, Software Engineering, we just had a paper accepted it's about a comprehensive study of bug fix patterns in Autoware and Apollo.
Oh,
Um,
great.
yeah, which we'll be using to help spur the automatic program repair. So yeah, I mean, more injected bugs would be great. Definitely. Yeah.
Yeah, yeah. So I think it'll be good to have a follow-up, smaller group discussion, like, with Clemson and with William, and then we can sort of make it like a little bit more Autoware centric, but we have kind of different twins and different simulators, and perhaps we can see, well, are they just there to demonstrate, the behavior, or can we use them in some more efficient way for mining? And if you could, whenever you have, could you share the paper you just mentioned? I think it'll be
Oh
good
yeah,
for,
absolutely.
yeah, cool. Thank you. Thank you so much.
Thank you
Anyone
so much
else
as
has
well.
questions, please go ahead.
Well, just one quick one then, Josh. If the application that you're scanning, that you're monitoring and stuff, if one wanted to go beyond, say, Autoware and add a speech recognition module for interaction with the robot and stuff, and kind of you're expanding the scope ecosystem of Autoware. Could that also be kind of tracked with your monitoring and get the input on errors and so on and so forth from that side of the equation as well? Would that be easy to add that additional kind of app or so?
So that's one of the goals we want to support. So for instance, if you want to add something like that, we want to provide essentially the test harness, the CI/CD infrastructure so that you can regression test that more easily, for example, and maybe at least fix some of the bugs automatically even.
Yeah, okay. And then that's awesome. And then have you just looked at whether it dovetails at all, like fulfills certain requirements, in the whole ISO 262 or other documentation, like, hard-coded certification quality parts, like whether this facilitates that?
Um, so not if you're talking, so ISO 26262, like road vehicle functional safety, that kind of stuff.
Oh, just in general, because there's so many moving parts to that, right? Depending on where you are, even, et cetera, et cetera. But with regards to actual certifications, regional certifications, regulations, et cetera, part of it does go into ISO in general. How well is your process documented and process ownership and changes, all that sort of stuff. And it kind of occurs to me that this is, facilitates that somehow.
Yeah, it would be great to expand to those kinds of standards or even regulations. Uh, that is something we'd really like to do, and if we're happy to partner up with anyone who's interested in that, so that we can move that forward. As I'm at least here, we're really the software and security people, and so that aspect, um, we're happy to look into that more, include that, bring in other experts who might, maybe even yourself, David, who would be uh, interested in acting as like a client or customer to us for these purposes, like Clemson is doing actually at this point.
Yeah, for sure, Josh. And I think it's it's cool that we could double leverage the PIX kit for whatever. And I think in general this is a very moving topic, because from the safety certification validation, everybody's kind of moving in the work that Chinmay presented is moving towards deployability, if you will, right? And that means homologation at the end of the day as well, and certification. And so that's kind of an unknown gray area, and so I think, but timely. I think I can see everybody's projects moving, being more transformative, more translational, and then it's going to be okay. Well, what does it take to run a PIX kit, other robot, RoboBus, whatever you happen to have in your inventory at that university, up and down the road, off campus or whatever. So yeah, happy to offshoot connect more offline on this topic.
Yeah, awesome. If we can provide some kind of broader certification, even like produce meaningful certificates, that would be great.
Great, great. And I think just to add to the good news, so from the Autoware COE, we have three vehicles that are available for you to use and on your site like that, right? So you can adopt these vehicles, and these are the Eve autonomy carts. These are the Yamaha based carts. They run Autoware on them, and then you can, and they have 360 lidars, Livox lidars in the front, and so these carts are actually much easier to work with than a retrofitted vehicle, because they are not like they're kind of integrated with Autoware already, and they're ready to go. You'll have to we'll help you update the version of Autoware like that with it, but and they're also very compact, right? And they're very slow moving, so they're useful for running on campus. So. And so I'll share uh, the example cart that I'm talking about is just the Eve cart, and let me sort of put that link over here. And so if anyone is interested, like, I think, Josh, if you have the space, then there are carts available. And then this would be used for our COE projects. So there are three carts available, and we'd be happy to, share them. And then they would essentially be gifted to the Autoware the member. And I think the normal cost of these cards is on the order of about 35K, like that, right? So you can think of it as a plus the lidars and the sensors and the computer, but this is like a so this is one of the benefits of being part of Autoware Foundation, right? So so just follow up with me if anyone is interested in these cards, and then we'll have to figure out the logistics to get it to you. Like that. All right, so let's move on. We have 15 minutes left, so we'll go to Hormoz, and then Rahul, and then uh, Jack, Abhijit, and Zira, and welcome. Yeah, go ahead, Hormoz.
Hi everyone, good to see you all again. It was, I don't know, I had mixed feeling listening to you, Rahul, at the start of the meeting, because I spent most of my today at the beach here, so the weather's very nice. We're at around 30 degrees every day.
Oh,
So
perfect, perfect.
yes, very nice.
We are coming to meet you.
Hopefully soon. Look, mate, as you may know, I recently received the documents relevant to the project, which helped me understand the scope of the project and what was the talk about the projects, basically. I'm also in the process of learning the software. I'm quite new to Autoware. But my what I have in mind at the moment, not knowing exactly where I can add value to the software, is going to be something about the vehicle dynamics. And I'm considering a project around cornering stiffness prediction, which I think would generate a good, bigger, major follow-up project, maybe even a PhD study on controlling the vehicle at the handling limit and integrating that into Autoware. So that's basically what I've thought about. I don't have anything ready at the moment, but I'll update you in the next meeting.
Great, great. Thanks a lot, Hormuz. So I think, one of the, just to complement your comments there, one of the directions that, Autoware, in terms of the R&D, right? I'm not saying Autoware as the main foundation, but what the COE's role would be is to explore, new directions, and essentially that is really looking at, beyond, the streets, beyond uh, just urban kind of driving, and so the interest is actually in looking at, even, so this might sound a little bit crazy, but there is a lot of interest coming from the governments in the direction of space, right, and space vehicles. And so this is something that Pojan had prepared. We had a discussion with Shinpei and um, on the really, like, what is the long another directions, because there is a lot of pull coming from different space agencies, and really looking at first, off-roading as a way to essentially move from the Autoware, current perception planning, modular, explicitly coded architecture to much more Autoware 2.0 architecture. And then that will also lend itself to these kind of, environments for Mars rovers, lunar terrain vehicles. And so this image here is a simulation environment that Pogen had developed both on Mars and for lunar landscapes to drive these special vehicles, right? So it's basically different environments with, and again, you can see that they have to go over, very much uh, uh, like a multi-terrain environment, and the vehicles themselves are kind of different from, just the ground vehicles that we have currently, right? So these are the current ODDs, and this is sort of the direction. These things are a little far out, right? So I mean, this is really
Raul, I actually think it's much more, and I know we've talked about this. This is kind of much more where there's value in Autoware.
Okay, great to hear that.
Yeah, because the main markets, the auto bus market, the car market, all those models, there is orders of magnitude more investment going in the private side. And whereas these micro markets, let me put it this way, are the places where the open source nature of Autoware and the ability to build derivatives provides a great deal of value. So I would encourage whoever's, if you're thinking about Autoware as a product context, thinking about flexibility and derivatives and going into micro markets is where there's going to be a lot more value than trying to do a robo shuttle or whatever, something like that.
Yeah, thanks for that, Rahul. I think that's a really, really good perspective. And especially I see you have visited and you've engaged with a lot of folks who are doing like things on the left column, and people who are, sort of moving towards the right side. So I think the like from, like what is our role as a COE, as academics, is really to explore these, um, more R&D related ideas. And So there are like now, these simulators. It's not running Autoware, but it is running Space ROS, which is a little restricted version of ROS. But there is already a start for us, right? And then as the folks from Clemson showed, the simulators are extending to off-road, but there's so much work to be done there.
Yeah.
And then there is also like some initial lot of interest in like funding, say from right now it's from the Japanese government, but frankly for us we don't care. If it can fund sort of COE projects, that's great. And that I think the funding scenario, I'm not so like I think it'll evolve, right? And we are right now sort of making like this poster here is like initial pitch in that direction.
But what I would encourage you to think about
Yeah.
is think about this in a theoretical context, which is where academics should be have more value, which is how do you build a simulation environment where you segregate the physics of the environment, whether you're talking about ground or water or space or something like that, and the design for experiment, and then these various things that sort of are the cornerstones of a virtual environment. How do you segregate them from an abstract point of view such that you can get some level of plug and play? And that's sort of the key thinking process, because once you can do that, you can start saying, okay, we can integrate AirSim over here while we can still use the random number generator for scenarios.
Yeah.
And so there's a lot of these intermediate mathematics that, if it's thought well, I think can be quite interesting.
Yeah. Thank you so much. So Hormoz, this is just to complement you were talking about, directions in dynamics and controls, and I think this will encourage a lot of learning-based pipelines, and I think several of us are, interested in, this learning-based control, but for, more challenging environments. And going back to what Rahul Razdan mentioned, is really we want to understand from like a more general mathematical perspective, so we can change the setting, we can change sort of the interactions, that right? So I just wanted to put that
That's
out
great to
there.
hear.
Yeah.
Thank
And
you.
if you want to have a follow-up, I'd be happy to discuss, and then to bring in the other folks, who also are interested in this, right? So I know we are running a little bit out of time, so whoever has an update and wants to go next, please. And even if it's a very small update, most welcome. I think we just want to have this dialogue and hear from everyone.
Can I jump in if nobody has any?
Please, Jack.
Hey, everybody, this is Jack Simon from University of California, San Diego. So I have been directly or indirectly involved with the Autoware Foundation for many years, I guess since the start. And then I actually was the one suggesting, hey, let's try to divide and conquer, each university contribute a little bit. My primary interest is a little bit different than space and research, but get as many undergrads as possible involved early enough with an easy entry point, right? Because other than that, people give up too quick in terms of using Autoware, and therefore our pool all stay on about the same size, right? The top labs with some graduate students, and the undergrads never really have the chance to get in. So my primary interest is trying to get an entry point with an affordable platform, and then sure, we feed that to the graduate school programs. So I live in San Diego. I'm a lecturer. I actually have a full-time job with Eli Lilly, and then I do research at the UCSD with labs and few robots in there. Thank you.
Cool. Thanks, Jack, and welcome back. Yeah, Alex, please go ahead. Yeah.
Hi, hello, thank you. I know we're very short on time, so I'm just going to share two quick updates. So I'm sharing my screen now. Hopefully you can see.
Yeah.
So yes, I'm very sorry. The web page for the Autoware workshop never. We asked the foundation, and they never opened it. So the workshop that was mentioned is aligned with IB's deadline. IB is very strict. They never change the deadline. So it's February 1st. I have I'm very sorry. I have abused of many of you with repeated calls for papers. So hopefully, a few members of our COE may be able to send a workshop paper. So deadline is very close. It's February 1st. Um, hopefully, perhaps some of you already have some working ongoing paper that you may be able to contribute and submit to the workshop. So looking forward to see you guys at the seventh Autoware workshop in Romania. That's one update. The second update is that we shared already with the simulation working group last year. So we have been working with a yet new simulator environment. It's called BeamNG. So it has been mentioned about physics and so on. So BeamNG is a soft body physics environment. So BeamNG is a game engine that is being around for about 13 or 14 years already. So it's old. And then they have the BeamNG Tech, where they expose sensors and so on. They created a basic ROS2 interface. We started toying with that ROS interface, and we found so many issues and solved them, and then made the Autoware integration. And we made the source available for everybody to use. The great thing of using BeamNG, at least for us, is that it includes maps in many places, including Japan. It has been quite a limitation with traditional simulators like Carla. So now we have an environment that has maps and assets of everywhere. Initially, for example, SBL, when we were working on the racing, etc., several years ago, all the effort to create the Indianapolis racing track. So BMG has the same track for years already, and they have several racing tracks. And it's not only about racing, but they have emphasis in insane emphasis in realism, and so that's great. The amount of assets, and then the possibility to have vehicles that crash, and take that into account so that we can evaluate the issues. For example, in this case, the issue, and then we integrated the simulator with the steering wheel before, so that we can also have actual feedback. We did a Seno integration because the ROS2 driver that BeamNG provided was very slow, so we integrated with Zeno. Now we have real-time performance, and yeah, basically we have no lag, no delays. The software is being contributed. We did some maps to evaluate, did the mapping, tuning, and so on. And yeah, finally we have BeamNG working with Autoware Universe, the latest version, and yeah, we can now start doing interesting simulations. Like, for example, what happens if Autoware is driving on a snowy road. So we did nothing, so no calibration or nothing with Autoware. Of course, Autoware is not prepared for this, but now we have a tool that is has high realism, and we can do many interesting simulations, and it's available. We're happy to provide the code. It's one of the projects that we registered in the COE project. So that's my update. Thank you so much.
Well, thanks a lot, Alex. This is very cool, and I think it just relates to our previous discussion on even going off-road into other environments. So I think this could be something we take forward together, and I'll also follow up with you.
Sure.
Yeah, and anyone who's interested, I think we can sort of work together to build up on this environment. Yeah, I think Abhijit, Ziran, any quick words? Sorry, we are a little bit out of time, but
Yeah, Rahul, I can do a last minute update just
sure,
in 1
sure.
minute. So again, the 01 here, assistant professor at Purdue University. We have been using Autoware for a lot of research regarding using large language models for autonomous driving. And so we previously implemented LLMs based on ChatGPT to enable like decision making for autonomous driving. And now we're working on deploying an onboard vision language model using Q1, the Alibaba's version, the Chinese version of LLMs, to enable the control perspective, which is driven by large language models or vision language models. And we are also exploring the possibility to have DeepSeek, which is, I mean, all over the news, to enable that and integrate that with Autoware. So that's the next project on our pipeline. But yeah, we have been using Autoware a lot for large language model driven autonomous driving. Yeah, that's all.
Cool. Very cool. Thank you, Ziran. And Abhijit, I see you shared 2 workshops that you're organizing.
Yeah, please consider submitting to these workshops. These are probably some good application domain for this community.
Cool. All right. Thank you. And with these links, Poojan, we can share after the call, so everyone has these in their email inbox. So today was a good quick updates from everyone. I think there's a lot of exciting stuff happening, and we are moving, according to our plan. And so Mike and Poojan will follow up with you all just to check in later in February. And I think this is really going really well. That we have lot of different projects and building up onto the universe, but also we are getting into new directions like what Alex showed here and what Hormuz is working on. And if you have any other questions, please let me know and I'll be happy to chat with you anytime. All right. Thank you, everyone, and have a great rest of the day. And hopefully, Hormuz, you can get another beach day tomorrow.
That's good.
All right.
Thanks,
Bye-bye.
everyone.
Bye. Ciao.
Thanks,
Thank you.
everyone.
Thanks,
Bye.
everyone.
Thank you.
Bye-bye.